You guys we're supposed to work on the worksheet that I labeled 4.1 through 4.4 review. So I wanted to kind of go through that, make sure that you understood some of the parts of this, because I know that a lot of you had questions on that. So on the first one, they gave us this situation. They talked about a group of high school students, and they found out that 87% owned a car, 57% owned a pet, and 53% owned both. And we were asked to make a Venn diagram to display the sample space of this process. We're going to call C owning a car and P owning a pet. All right, so our Venn diagram. We got the two situations with a car and a pet. We know that's going to fit inside our sample space that I'm going to have for a rectangle. All right, I always start again with what's overlapping, or the intersection. In this case, they said 53% own both. So if you want to write that as a decimal or write it as a percentage, it's going to go in here, though, either way. So I didn't leave myself much space there. Let me redo my circles so they're a little bit bigger. All right, so I'm going to put it as a percentage. So I got 53%. And then we have each situation where the car, we had 87% total, but I've already dealt with 53% of it. So I'm going to take 87 minus 53, and so this section will leave me with 34%. And then owning a pet, that would be the entire pet circle. And 57% owned a pet, but we already dealt with 53% of them. So that leaves me with 4%. So if I put all those together, right now I have 34 plus 53 plus 4. So I have 91%. So that means I have 9% on the outside. All right, so part B wants to know, what's the probability that a randomly selected student owns a car or a pet? So we can do this a couple ways. One way, though, we can think about, okay, what's the probability they own a car, which we know was 87%, plus what's the percentage that they own the pet, which we know is 57%. But I'm going to take away the percentage that own both, which is 53%. So if I add the 87 and 57, and I take out the 53, I get 91%, which really matches what I had in all three of my areas inside the circle. Okay, this part C wants to know, what's the probability the student has a car, but it does not have a pet? So essentially, I'm going to look at what's inside the car circle, but I'm going to ignore the part that's in the pet circle. So the part that has a car and not a pet would be 34%. Then the tricky one, part D, this was a conditional probability. They want the probability that a student owns a car given that they own a pet. Well, this is where our formula is going to be helpful. So I'm going to look at what's the probability they have both, car and a pet, divided by the probability of the given fact, which was that they had a pet. Well, we said the overlapping part was 53%. So I'm going to take 53 divided by, we said the probability they had a pet was 57. So I could leave it as that fraction, or if I take 53 divided by 57, I get 0.929. I'm going to say 0.93. So the probability is about 93% that if a person has a pet, we're given that person has a car. All right, number 2 had a two-way table. And it seems like we're doing pretty well with the two-way tables. This one was a little bit trickier because I didn't fill any of the table out. You had to take the information and put it into the table. So let's see what all we had. First of all, we had 80 children who went on the school trip. So right away, I can put 80 for our total. Some of them went to London or to York. 23 boys and 19 girls went to London. So I'm going to start with that. So 23 boys, 19 girls, or 42 total people went to London. 14 boys went to York, which means there were 37 total boys. And that's all I gave you. So you had to try to figure out the rest. Well, one thing we can figure out is if I have a total of 80 people, 37 of them have already were boys. That means that we have 43 left for girls. And if 19 of those girls went to London, that means 24 of them went to York, which means I should have had 38 that went to York total. And we can check it, 42 plus 38 is 80. All right, so now that we have the table, let's see if we can answer the questions. The first one wants to know, well, what's the probability that I'm going to choose a girl? Well, if I look at my totals, I had 43 girls. I had 80 students. So I had 43 out of 80. If we want to divide that, that's going to be about 0.54. What about the probability they went to London and they were a boy? So I'm going to look at the data, and we had 42 people who went to London. Plus, if I look at the number of boys, we had 37. And, oh, wait a second. It says and, not or. I was thinking or. We want to know what's the probability they went to London and a boy. So this is actually going to be easier. So I'm going to look at where they overlap. And London boys were 23. That's out of 80 students. So you can leave it as 23 out of 80, or you can say 0.29. I read that one wrong. The next one is an or situation. So the probability they went to York, so that would be 38, first of all, total people. Or they were a girl, so that was 43. But I'm going to take away from that the girls who went to York, which was 24. And once I'm done doing that, that should all be out of 80. So 38 plus 43 minus 24, that gives me 57 out of 80. Or 0.71. Then the last one is a conditional. It says, what's the probability they went to York given that they were a boy? So that means I'm only going to focus on the data concerning boys. Well, in that data, 14 went to York out of the 37 boys that we had in our data set. And 14 out of 37 is about 0.38. All right, so being able to use a two-way table, hopefully we're getting somewhat comfortable with that. I know some of you, when I surveyed you, said that was a little bit confusing. Hopefully that's getting a little bit better. When the 3 through 5 was also a two-way table. This one, I gave you a lot of instances where they're conditionals. So let's see what's going on number 3. It said, if a person in town is selected at random, we want to know what's the probability that the individual is employed part-time, given that he or she is between the ages of 35 to 39. So since they talked about them being ages 35 to 49, we're going to focus only on that data. So in that data set, I'm going to figure out, first of all, how many were employed part-time. Well, in this one, there were 179. And since I'm only looking at that data, I'm going to look at the total there, and that was 864. So our probability is just that fraction, 179 out of 864. If you prefer decimals, that's going to be about 0.21. Then the next one. The next one wants to know if a person in the town is selected randomly, what's the probability that the individual is unemployed given that they were over 50? So now I focus on the 50 plus data. And the 50 plus data, the ones that were unemployed, were 173. Out of, in that data set, there were 778. So I take 173, add a 778, and I get 0.22 if I like the decimal. So the nice thing about the conditional is it restricts how much data I have to look at. Well, then the last one for this data. A person from a town is randomly selected. What's the probability the individual is employed full-time, given that he or she is between 18 to 49? Well, what that means is I'm looking at this entire set of data now. Because that would be the group from 18 to 49. In that data set, I'm going to focus on the employed full-time. So I'm going to focus on this column. So if I add those three totals in that column, the 185, the 348, the 581, I get 1,114. Out of, now I'm going to look at these three in my totals. So 536 plus 442 plus 864, I get 1,842. And again, if I want to get the decimal amount, you can leave it as that fraction, but if you wanted the decimal amount, you're looking at about 0.60. And that would be the probability for that one. So conditional probabilities with two-way tables, that's going to restrict your data. All right, then the last one, they said, suppose you're going to flip a fair coin 3 times. We want to list all the possible outcomes, or in other words, the sample space for flipping a coin 3 times. Well, I'm going to set this one up with a tree diagram, even though we hadn't necessarily done tree diagrams when you did this initial worksheet. So a tree diagram here is nice because it helps me stay organized. So the first thing I would do is I flip that coin, and that tells me I have 2 options. I have heads or I have tails. Now, the other day when we did this, we talked about labeling the branches with the probabilities. Well, in this case, the probability is always going to be a half. So I can label those, but since it's equally probable or equal probability there, I don't necessarily have to label them. Just for practice, though, I am going to go ahead and label it with a half for each of those. All right, so I flipped the coin, I could get heads or tails. Now I flip the second coin. Well, the result is the same. I could get heads or I could get tails. And that's true for either situation. The probability for that doesn't change, so I'm still looking at a half for each. Okay, now I flip the third coin. I can get heads or tails, heads or tails, all the way down. And again, the probabilities are all a half for that. So that would be an acceptable listing of our sample space. If it helps to make a systematic list, I could now just follow the branches. So for instance, I can go heads, 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 following that first branch. Or I could go heads, heads, tails, following the second branch. Then if I went heads, tails, heads, or I could have gone heads, tails, tails. So those are the 4 situations that would happen if I flipped heads the first time. Then I can go down to the bottom set of branches. So if I follow along, I have tails, heads, heads, tails, heads, tails, 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 heads, or tails, tails, tails. So it turns out I have 8 different possibilities here. Well, they want to know what's the probability that tails will come up at least twice. So I go through my list and I see, well, how many times does tails come up at least twice? What happens here? It happens here, here, and here. So 4 out of those 8 situations, or the probability is a half. So hopefully that helps out a little bit with that worksheet. We'll keep practicing things as we go through some more things with probability.